Hey everybody, I'm James and welcome to the Esprit Tech live stream episode 6. Today we want to go over some of the new product available through Esprit. That would be the Esprit Elite line of product, some of the sensors, motors, and ESCs that are available in that lineup. We'll also want to do a little bit of classroom for you guys on our sequencer with the Jeti transmitter system. We get a lot of questions on that, and I want to give you kind of a different way to think about or how to set up that sequence. And any questions that you have, make sure that you pop onto the comments. We are monitoring the comments here, myself, as well as the team are going to be watching those questions to help answer those for you. So if you do have questions while we're going through either of the segments, make sure you jump on and ask those. Esprit Elite. So Esprit Tech recently, well I guess last year, started taking a look at our market and what's happening in the industry with the manufacturers, and we made the decision to start launching product under our own label. All of the product that we're doing is product from high-end manufacturers that we already deal with. So we have motors, and speed controllers and some sensors that mate with or match with the Jeti system. All of this is check-made product. It's very high-end product like you're used to getting from us, and it's available through the Esprit Tech website. I want to go into a little bit of what we offer. The first thing that we did were our motors. So we have motors ranging from a 10cc electric all the way up to our 105 series motor, 10530, which is a 200cc electric setup, 1416S type setup. These are precision wound motors, very good bearings, very good shafts, extremely powerful motors. Typically what we see out of our 30cc motor is what you're seeing out of 35 or 40cc motors from everyone else. Our 105 actually was featured by Gernot Brookman, a Jeti pilot, in a 40% yak. Tremendous video. If you get a chance, go on and search that flight. It's a 10530. Beautiful line of motors. We followed up our motors with a line of speed controllers. These are very similar to the Jeti Spin Series controllers. They program with a Jeti Spin Pro box. They range from 55 amp unit with a BEC all the way up to the 165, which does not have a BEC. That's a 165 opto. These are fully programmable controllers, all the way down to programmable filtering, motor count or pole count, timing, you name it. It's all adjustable, including the ramp-up times, and of course your start-stop times for your throttle. Very good controllers built on an unbelievably reliable backbone, which is the Spin Series controller. You'll notice if you log onto the site, they are extremely cost-effective controllers. Because we're labeling for ourselves, those that are OEMing for us, we're able to offer those at a very discounted price, but we give you all of the features of the higher price units. So make sure you check those out on the site. The last thing that we're bringing into our family of product with the Esprit Elite series are some sensors. Now these are sensors that are not offered directly from Jeti, but are designed to work with your Jeti transmitter system. So all of your DS-DC transmitters, these sensors will work with those receivers and work in that package. Brought two sensors for voltage, amperage, and capacity, as well as a polyfuse. I want to go through a little bit of each of those, show you how those are packaged, explain a little bit about what they do, and then we're going to go ahead and set them up in the transmitter and let you take a look. So the first one we want to cover are the polyfuses. Now the polyfuses are fantastic. These are available for not just Jeti users, but any transmitter system. This is an inline, non-programmable polyfuse. It's a 6 amp standard load and 50 amp maximum load. These would plug in between your receiver and your servo. You can run these on all of your outputs or a single output. They are sold individually, like what I have here, or you can buy them in a pack of 4. Very simple to use. There's nothing to do as far as the programming side. You literally unplug the servo that you'd like to replace, plug in the polyfuse, and plug the servo into the other side of the polyfuse, and you've done. You've now added overcurrent protection. Where this is really great is on your big scale models. Anything with mechanically activated gear or gear doors that can jam, anything that can jam up and draw power or large amounts of power from the system, draining the battery or causing a short, that's where you would want to add these polyfuses in. Very simple, very small. They don't take up a lot of space, and they are cheap insurance in your very expensive models. Packaging is fantastic, not a lot of waste. The manufacturer on these has decided to package these in a poly bag, so there's not a lot of waste to go through. They are clearly labeled, and each one of these devices does come with a instruction set to show you how to use them. Like I say, with the polyfuse, there's not a whole lot to the instructions. They are really plug and play. But those are called the Elite SFuse, and again, they're sold in single and in 4-packs. So anybody that is flying a scale model, big scale sailplanes are a really good example of that. Typically, they have great big, mechanically operated gear like this. With a single servo, and everybody knows if that happens to jam up, that is going to draw a lot of current, tie up the system, and potentially cause a crash. So adding the polyfuse, again, really cheap insurance for that. Bear with me just a second. I am going to try to pop my comments out here so that I can see them. All right, perfect. Do polyfuses reset themselves? Yeah, polyfuse is basically a self-healing fuse. It's typically a thermal device. We know where you're trying to prevent overcurrent, but the higher the current, the higher the temperature through the device. That's how they typically measure that. When that polyfuse reaches its limit, it separates. If given time, it will reheal or reseal. One of the things to keep in mind with any polyfuse application, whether it's in the CBs or a standalone unit like the SFuse, you do want to let that heal no less than 24 hours before you put it out. And the other thing is, if you do have an overcurrent situation and you lose, and a polyfuse goes, don't just ignore it and go back to fly it. Make sure you get into that model, figure out what caused that polyfuse to go. Very easy to do. Measure the current in the system, and take a look and see why that's happening. And that kind of leads us into the next device that they've come up with. The next device that we want to launch with the Elite Series product is our Voltario S30. There are two Voltario devices. One of those is an S30, one is a T30. The first one we'll cover is the S30. The S30, again, really minimal packaging, very nice. Not a lot of waste to throw away, not taking up a lot of landfill space. The bags are fantastic to reuse for other electronics if you want to store them. Again, a very, very simple little device. There is not a whole lot to it. Size-wise, it's very similar to what you saw with the SFuse. Now, what this is this is a current sensor for your servo outputs. This will measure voltage amperage capacity going to the servo. And again, it will simply plug in line between the receiver and the servo, and then you will run an extension from the device over to your telemetry input in the Jeti receiver, and you'll be able to see the current that's being pulled. Actually, if give me just a second. Oh, actually, I think I might have one. Let me grab an extension. I want to show you how that runs. I'm going to have Jason run a video for you for just a second. I'll be right back to you. All right, perfect, guys. Welcome back. Thanks for giving me a second there. We did have a question come in while the video was running. I have S30 measures capacity of what? It's a really good question. It's actually capacity used by that output. So what we're going to do is I've gone ahead and I've powered up the system with a transmitter. I've plugged in the S30 into a servo output, and I'm going to run that to my retractable gear, and you'll be able to see what's happening in the transmitter, what's being measured, and how that's going to work. I'll show you how we'll set that up. What you're going to need to do, Jason, if you would go to the overhead. All right, perfect. So this is my S30. I have plugged it into the servo output I've chosen to use for gear. The one thing that you're going to have to add to the system is your male-to-male connector. And see if my fumble fingers can get this plugged in here. Very good. That will plug into the telemetry input for that receiver. So we've done that. Now that output from that SFuse is going to go over, and it's going to go into my retractable gear. Let me get this in a position where it's not going to kill us. All right, perfect. Now, in the transmitter side, which I'll show you in just a second, with this, you're able to measure what's happening. But as you can see, with that in place, let's try and not take off a hand here. Love these big cumbersome things. There we go. If I hit my gear switch, my gear is going to come out. If I hit again, gear is going to come back. So it does not interrupt how the device functions. But what it does do is measure what's happening. So I'm going to set that off screen for a second. And I'm going to bring in the transmitter, and let's give that a second, see if we can pull back in and focus. There we go. So if I go into my timers and sensors, go into my sensor logging setup, you can see that my Voltario is showing up in the system. So it is doing what it's supposed to do. So if we click OK, we go into our displayed telemetry, click Add, go to telemetry, and choose from what's happening there. So I'm going to go ahead and double size that. I'm going to add my current, and I'm going to add my capacity. The capacity that's measuring, sorry to get back to that question, again, is the battery capacity of whatever device you are operating on that particular output. Where these come in handy is the ability to individually go through your entire system and take a look at what is happening on each of those outputs. So if you set up a model and you have a feeling that one of the outputs is going to draw more current, maybe a little too big for what you're using, you have the ability to put the S30 in line and measure the current directly being used or being pulled by just that output, rather than taking a look at, say, a Central Box 200, the current, and seeing what's being pulled across the entire model. You're able to look at it servo by servo on any output where you have an S30 installed. The other thing with the S30, which is really fantastic, is you have the ability to log into the S30 and actually set a fusing or an overcurrent limit protection. So once it reaches that current limit, it will pull power from that output. So this is a device that you can plug in and use temporarily, servo by servo, to look and see what's happening. It's also a device that you can plug in and leave in as a fused output or as an overcurrent protected output. So again, takes what we've done with our SFuse and just adds another layer to that. So very, very capable device. If you were to operate your gear, you can see that it does tell you what it consumed to do that, as well as the amperage that it's pulling to push that gear. Let me go ahead and flip that down like it would be if you were flying. So there's my 3-second down rate on my gear. Coming back the other way, you can see once I'm up and locked, I'm pulling about 0.08 amps. It ranges because of my handshake over here. So that would tell me that I have a little bit of work to do to get that back down to an even lower number. So you could do that through tuning the throw, or tuning the output of the servo. In this case, we're using Jeti Ditech servo, so I would simply go into the servo programming and change the amount of throw in the servo, the amount of travel in the servo. So really nice, easy setup to use. So I'm going to set that aside for a second, and I want to go into one of the other parts of the device. So because we have that plugged in, I can jump into my applications menu, jump into the Jeti box, go into my devices, and connect directly to the Voltario. In the programming, if you go into the settings programming, you can see the capacity reset. You can change when it resets the value for capacity. You can also set up the shutdown current. So you can limit how much current this device is capable of outputting simply by going into the Jeti box application or with your handheld Jeti box and making an adjustment to that setting. So a really great device, very capable of measuring the outputs, of acting as an overcurrent protection for your servos. Something that I think that is going to be a benefit to you guys that have a model that may be too small to fit in a Central Box 200 or 400, but you do want that overcurrent protection, and you do want that capability of reading what that output is putting. Imagine, say, a 3 or 3.5 meter scale sailplane with a mechanical gear. That's a very small fuselage. You're going to pack it full of batteries if it's an electric, pack it full of lead if it's a tow. So you don't have a lot of space for electronics. In that situation, you could be flying with a standard receiver and run this S30 just on that gear output and know that you were protected from that situation. The other way to know that is the next device I want to show you. Jeti did introduce another device into the mix, or not Jeti, sorry, Elite introduced another device in the mix recently. Just hit the website, and that is the Voltario T30. Now the T30, just like the other product, comes in this really nice foil bag packaging, eliminating a lot of the waste again and giving you something you can reuse down the road. Does include a very nice little manual. If you have any questions with the manual, reach out, because I did some of the translation on it. So if it's not good enough, send me a message and we'll see what we can do to help clear some confusion for you. All right, I have Kirk sent me a message, but it should be labeled a totalizer, not current used. Total current used, not capacity of a source. You are correct. It does not give you the capacity, total capacity used from the source. It gives you the capacity from the source used by that output. So unfortunately, totalizer isn't really something the guys are using from the manufacturer side. We go with what they do. But you are probably correct in saying so. But we appreciate it. The next device, again, very small device. Not a whole lot to it as far as taking up space in the aircraft, although this is an extremely usable device by comparison to some of the other things that we've seen out there in the market. What this device is for is this actually gives you the ability to measure the current between your single battery source and your receiver. So this would give you similar capability to, I'm going to go ahead and switch back here. Let me pull this back up. This would give you similar capability to, say, your Central Box 200, where you have the ability to measure voltage, amperage, and capacity from your flight pack. So I'm going to go ahead and pull down my receiver system here, and we'll disable that. And we'll get rid of the noise in the background. I'm going to go ahead and get this out of the way just so we can clear the board a little bit. But we'll go ahead and put our Voltario T30 in line. Now you can see it is a, pardon my big head in the screenshot there, it is a simple device, just like everything else that we have shown you so far. I'm going to go ahead and go battery to battery here. And we are going to go to our telemetry here. And make sure we are reconnected. One of the nice things with the Voltario T30 is we are going to sell that two ways. One of those is going to be with a touch switch, like what you see here. Really nice little device. Rather than needing a magnetic key or using a mechanical switch, you simply plug your touch switch in, which we're going to do. Let's make sure we match our polarity. And a touch switch is a really nice device because you're able to adjust the sensitivity of the device. So simply mounting it either in an exposed location or inside the fuselage, it will work through your fiberglass or composite fuse. The sensitivity is adjustable so that it's not easy on and easy off, so that it actually requires you to make contact with the device. I am incorrect. Make sure we're in here the way I need to be. Oh, I plugged in, so now we're going to need to reset power. Bear with me just a second. Gotta love playing with new toys. All right, that's in, and that's in. And let that come up and run. All right, perfect. So what the switch does is allows you to adjust the sensitivity. Let me jump in and make sure we can see. Pull that out. There we go. I am not making good connection. So that is just my big fat fingers is what you're seeing there. There we go. We should have contact now. Well, it happens to the best of us. We do have some failures on occasion. I am clicking the wrong thing, and who knows what it is that's causing me such consternation, but it definitely is me. I am sure of that. Let's make sure one more time we got our polarities are correct and everything is as it should be. Guys, this is the fun part about doing live TV or live broadcasting, is you don't get to do retakes, you don't get to change it and do it again. It's really fun when things are working and then they decide they're not going to work. So more than likely I'm having a sensitivity issue here. Well, our switch is not going to work. One of the nice things that we do have the ability to do, of course, with this is because it is a plug-in switch, you are able to add an R3 wireless switch in place of the touch switch. It will function in the same capacity as the touch switch does. Only it will give you the wireless switching like you're used to on your central box, you know. And I'm hard-headed. I'll just keep trying every time. And it looks like it is going into a standby mode, so something is not functioning properly with that switch. But the one thing too, here we go. Shut it off, turn it on. Well, it doesn't look like it's going to work for me. I'd love to be able to show it to you, but it is not doing what it's supposed to do. There we go. Now we're on and running. Okay. See, user error. It's always user error. One of the things with it is it has to come on and recognize no resistance, and I wasn't giving it time to do that. So when you plug the battery in, you do have to let it go through its cycle, set that zero resistance, and then it's looking for that resistance from your contact. That's how they adjust the switch for sensitivity, is it adjusts the resistance required to make that connection. Just like the other Voltario sensor, now that we're back on track and jumping into it, it will show up in your sensor logging setup. Because it's a new device, I'm going to go ahead and reset that. And let's go ahead and go here and reset that one. Perfect. So let that go out and look for that new sensor. Let's go ahead and plug that in so it sees it. And there we go. Now our sensor's popping up and populating. So we're going to go ahead and go into our displayed telemetry. And just like with the other sensor, you are able to go into telemetry and choose the parameter that you would like to display. We'll do our current and capacity just like we did before. Jumping out into my main screen now, you can see that displayed. So you can see that change, and let me move this out of the way so you can see that. But you can see that displayed immediately. Let our little camera system focus here. It's always fun doing live, and my cameraman is in the back, absolutely dying. So if you hear a little noise from the background, that may be what that is. So we'll go ahead and go back in on the front facing. So now you can see if I run the servos, you can see that it does measure that current. And this device, Kirk, is measuring the full capacity pulled from the pack, because this is measuring between the power source and the device itself, or and the receiver itself. So it's measuring the current and capacity from all of the outputs in the receiver, very similar to what you would have in the central box. So that is the 3 sensors. Let me go ahead and pop the radio out of the way. Let me bring that back for a second and give you an idea. When you put your finger on the sensor, it'll start to flash at you. Take it off, and it will shut the power down. And as you can hear, we've lost connection to the device because we have powered it down. Very simple to use, and we are having a really tough time with focus today. Let me pop out a little, and we'll pop back in and see what it does. There we go, very good. But those are the Voltario devices that are new to the site. Go ahead and check those out. Make sure you check the links in the comments below. We have linked the locations so you can go directly to those new devices. If you have any questions on any of the Elite Series product, whether it be the motors, speed controllers, or the new sensors, make sure you don't hesitate to reach out to us. I'm going to show you a little programming video we put together specifically for one of our customers on a request, and I'll be right back to you in just a bit. Okay, today we had a request from one of our customers. He had a problem where he was mixing his rudder to his steering when the gear was coming down, and the problem is there was no way to hold that mix off until the gear was all the way down without building crazy sequences. With the new firmware in the radio, you're able to do that through a new mixing capability through a logical switch, and we'll show you what we did. We went in first and we created a timer specifically for this purpose. So in my timers, my timer 2 is a 5-second countdown timer with no report type, and it has to be a standard timer. And then the switch to activate the timer is going to be that gear down. The switch to reset is going to be gear up. So that's the first step. Second step will be to go into your logical switch and create a logical switch. What I created was a logical switch that included as control 1 my gear down position, and my control 2, now with the new firmware, I'll clear that out. If you go into select input control for your new control and click the plus sign, we've added a whole lot of things that you can use as inputs for logical switching, and one of those is timer. So now I've added that as my control 2. And you'll see if I come out and go back in, it actually waits until that timer expires before that switch is turned on. I used AND as the condition, and we assign that in the mix. So now in that mix, when he flips to his gear down, there's a 5-second delay before that mix is enabled. Figured that'd help you guys out. If you have any other questions about the strange mixing, just hit us up either via email or phone. Thanks, guys. Hey guys, welcome back. Hopefully this segment goes a little bit better. Don't worry, I don't have to use any electronic devices, so I don't think we'll have any issues. One of the things that we get the most questions on, or I get the most questions on through the tech line, is how to set up the sequencer. I think a lot of what happens when you're setting up a sequencer has to do with asking the right questions before you start, and getting the right information ready to go before you try to set up a sequence. One of the biggest ones that we run into kind of relates to the video you just saw. That was how to limit steering, when your gear is retracted. We run into a lot of issues with gear doors and gears, especially on sequencers, where guys have a really hard time putting together how to do it. One of the things that I always go back to with them is asking questions. Okay, how long does this take? How long does this event take? And that seems to be the issue. Well, I don't really know. Well, that's going to be critical to setting up a good sequence. You want to have the best information that you can when you start, so that you know exactly where to put your time points in. I've got this great big mechanical gear here, and we want to kind of use that as a visual reference. So one of the things you're going to want to do when you're setting up your gear, you're setting up your doors, first is make sure that you're only connected to the first piece to set up the second piece individually. You don't want to just try and set this up and run it, because you're going to break a gear door. Something is going to happen. You want to get each part of the sequence working correctly before you move on to the second part of the sequence, because that's going to give you a time reference also. One of the things is understanding, of course, how that sequence is working. So there's a couple of lines that you need to recognize on the sequencer program itself, what they represent, and of course how we're looking at time intervals. So when you're setting up a sequence, and we're going to use gear and door because that's probably the most common one, is there's always time involved. There's an amount of time when I throw that switch, how long it takes that gear to open. Well, I have a 3-second delay set in that gear. So with the mechanical action and the gear coming up, that's about 3.5 seconds. So I know it takes that gear from the time I throw the switch about 3.5 seconds to open. So that's one of the things that you would of course write down. So I'm gonna go G is gear. We'll go up is my direction, and I'm gonna go 3.5. That's my second interval. So so long as I know that time, I'm able to interpret that and put that into my sequence, and it's important. So then I hit my switch down. I have a 1-second delay, so that's going to give me about 1.5 seconds on the closing. So again, we're going to go ahead in my little notebook. I'm going to write gear down is my 1.5. So if I had an imaginary gear door here, which unfortunately I don't, it's going to be a much shorter stroke. So let's give that a time from, let's say, door open. We'll give that a 1 second. And we'll say door closed. We'll give that a 1-second time. Now you have the information that you need to run this. Getting into the next part of it, which is actually building that sequence, there's a couple of things to understand as well. And we will get into the transmitter. For now, I want to go ahead and stick with just a little classroom style, because it just seems like the thought process is the tough part for everybody. So I have my values that I want to use. So when you're looking at setting up a sequence, there's a center line, and you like my nice straight line. That center line represents your travel, and that is your zero line. You can think about that as 0% or 1.5 milliseconds, however you want to think about it. In actuality, there are really 3 lines, right? This is your negative 100, your 0, and your positive 100 lines. So we know now how much time that we need. The other piece of the information that we're going to need is at what points we want each of these to start. So if we're building, let's say, a gear sequence, we know that it's going to start in our closed position. And we're going to use whole numbers. Your numbers may be a little different because your closed gear position may be negative 83%. For this, in this case, at 0 time, we have to have a starting position. So the first point that you're going to put in is the start of your sequence for this particular side of the sequence, and in this case we're working on the gear. I know that my gear at closed position in this example is going to be at negative 100%. So the first point that I'm going to input in my sequence is point 1. My value for that point is going to be negative 100%. Don't forget that you add those points as you go through the sequence. So we're going to go through, we're going to put that in. We know that in our case, we're going to have our door open first. So you want to build a frame of reference. You know, you want to build kind of a time interval in your mind. So when we flip our switch, which is our X point, let's say we want 1 second where nothing happens. At 1 second, we want our gear door to open. That's a 1 second period. Let's say half a second later, I want my actual gear to start to deploy. So we know that takes 3.5 seconds for that event to occur, and then it's going to remain open. If you want to close the door behind the gear, then you will need to put in another point. So as you're building the gear, if I'm just building the gear, so this is my door, this is my, sorry, let's make that a G, this is my gear. So we know that we're going to wait 1 second before anything happens, we're going to wait 1 second while the door opens, and we're going to add another half a second. So my next point that I want to put in, this is at 0 seconds. My next point that I want to put in on my graph is going to be at the same percentage because I don't want anything to happen. I want to maintain the value that the gear's at rest, and it's going to be at 2.5 seconds. So if I put a point in, that's going to be at 2.5 seconds. This is 0 seconds. From this point, I can determine what I want to happen. Now I can literally go from this point 0.1 seconds forward and put another point at 100%, or I can set it in that I want to go 3 seconds out to put my high point in. That will mean my gear will open slowly over that value. In any case, this initial period of rest, we don't want anything to happen. So from this point forward is where things are going to start to happen, where we want the gear to come up at. So let's say that I want to drag that out. So I'm going to come out here to 5.5. I want it to come full open, and I'm going to put my point in at 5.5 seconds at 100%. So at this point now, we've achieved a sequence going out. We flipped the switch, it's waited 2.5 seconds, and over the next 3 seconds the gear has deployed, and now the gear stays up. You can go out to another point and put a second point in, but at this point this is not necessary. This is my opening sequence for my gear. Now keep in mind a lot of these things are going to happen in different time intervals, so that's why in the setup you're able to set up an asymmetrical mix. So the biggest thing is setting it up asymmetrically means that you're going to build two separate sides of a sequence. I'm going to go ahead and pull over the transmitter, and hopefully you guys are able to see the screen enough to make sense of what's happening. But if you go into the menu and go into the sequencer, you see a very similar setup to what we were working on. You can set a switch for your sequence. In this case, we're working on gear and door. That would be our gear switch that would activate that sequence. Use any switch you want to on the transmitter. So for now, we'll just go ahead and throw a switch. I'll go ahead and jump back in and reverse that so it looks pretty to me. And we'll go ahead and set our first time interval at 0 seconds. So we're going to click Add. We're going to go ahead and give that a value of negative 100% like we discussed in our example. Once we have that value, now we can move over to our next point. So we want to go ahead and dial up 2.5 seconds. We want to click Add so we have that point, and we want to maintain the same value. So we're all set. From here, we're going to roll out again in our time out to 5.5 seconds. We're going to click Add to create another point, and only this time we're going to go ahead and dial that up to our 100%. Let me go ahead and get to 0, double click this, and make that 100%. So now if we were to throw this gear switch, we can see that it was moving out the sequence. Let me go ahead and get to the start. So I throw my gear switch, it waits to 2.5 seconds, it starts to open, it hits that open point. Well, we know that it took 3.5 seconds to open, it took 1.5 seconds to close. We have gear door involved. If I was just to allow this sequence to run symmetrically, run backwards the same as it did forwards, the gear and the door would collide. We'd have damage, possibly a short, a lot of things that we don't want to happen. If you scroll down, let me go ahead and get out of that line, scroll down to advanced. You can go down and take a look at type of path. You can change that to an asymmetrical. Now, if you go back into your sequence, you are able to create the second half, or the opposite direction of your switch. The overwrite channel in this case, of course, is gear, which is something you want to assign once you get everything working the way you want to it in the monitor. We don't want it to cycle. We do want it to always finish. Always important. If it's the gear, you don't want it to be interrupted by something happening. You want to go ahead and get it fully extended, fully retracted, so you don't end up jamming something up on the way. So go ahead and click OK. We'll switch our gear switch, which of course is activating our mechanical gear here, and I'm going to go ahead and pull that offline so we're not pulling power. Now we would build the second half of the sequence. The second half of the sequence would start with the gear open and go to gear closed. So your first point, your 0 time point, if we click add, is going to be at 100%. If we're working on doors, there would be a little bit more involved. If we're closing a door behind the gear, it would just mean that we would need to extend that gear out position out in time. So let's say that the door closed behind the gear. That means we need to now wait again 2.5 seconds before we begin to retract the gear. So we know immediately that our second point is going to be at 2.5 seconds. So we'll go ahead and roll out, give it a point at 2.5 seconds with a value of 100%. From that point now, we can close that gear. So we can go ahead and select our next point, which is a mere 1.5 seconds, because I want it to close a little quicker than it comes out. So we'll go ahead and go out to 5 seconds. We will add a point, and we will give that a value of negative 100%. So now if I flip the switch into the gear up or gear down position, my gear waits for the door to open, the gear comes out. Once we program the door sequence, the door would close behind the gear. When I flip the switch, the retract stays open for 2.5 seconds, enough time to clear the door. The gear comes down. Now we can close the door again. So if you're going to go on now and build that door sequence, you would just go ahead and exit. You can go into Q2, which is a new sequence, and you're able to, Q3, Q2 is your second half of your primary. So we would go into Q3, and we could start to set up our door. So again, we're going to use the same switch. So I'm going to put it in the position I wanted. I'm going to go ahead and select that switch, and I'm going to go ahead and create my line. So always hit your plus sign right out of the gate. That's your add. That creates your 0 point, and you can add or create the value for the 0 point. So in this case, I'm going to operate the same. My closed door is 100%. My open door, or negative 100%. My open door is positive 100. So we're going to work with the same values in this example. So we know we've already discussed we want that door to remain closed for the first second when we flip the switch. So we're going to scroll out 1 second, and we're going to click to add our second point. Now we can go ahead and go out 1 more second for our third point and give that a value of positive 100%. So now my door is open. So if you were to look at this on the monitor, I would flip the switch. Nothing would happen for the first second. During the second second, the door would open. At 3.5 seconds, my gear would start to deploy, and it would take 3.5 seconds to deploy. So that would give you an idea of both of those things working correctly. And don't forget, you always want to go back into the system in the monitor before you test things with servos. You want to make sure that you don't have anything crashing into each other. Just like with the opposite setup that we just had, we know that the sequence is not going to be the same working in either direction. So we want to go ahead and make sure that we make this an asymmetrical sequence. And of course our overwrite channel, we'll call that gear 1. We'll pretend that that's our door. Once we've done that, we can flip to the second side of our sequence and we can create that again. Now again, same thing that we had before. You are going to use the same time intervals that you used in the last sequence. We're going to wait 1 second. The door is going to open. Then the gear is going to start to retract, which takes 1.5 seconds. We know that total delay time is 2.5 seconds from the start. So we can input that time by adding our first time at our 0 point. We know that in this case we're going from a closed door to an open one. So we're going to make that value 100 because it's going to be negative 100 because we know that we are already working from a closed door. So it's going to start closed. It's going to wait 1 second, which means you're going to add another time point in at 1 second. And we are going to give that the same value, and then our next point will be our change value. It's really, once you break the sequencer down into exactly what you want to happen, it becomes very easy to use. One of the things I like with the sequencer is you are able to create logical switching, tie that in as the switch for the sequencer to prevent some of the mishaps from happening that we've discussed in the past. Using that short mix that we created in the video, using that to affect the sequencer works very well. So then your gear switch does everything that it's supposed to do, including turning your nose wheel steering on while still giving you that delay. So there's a lot of things that you can build up around that in the Jeti system to make this work. Don't forget there are other things that you can do like adding Jeti Hall sensors to report to the transmitter when the gear is up or when the gear is down. Those are done by changing the outputs on a receiver to digital input or output, typically digital input in that case, using that in combination with logical switch to trigger an event. So there's a lot of stuff that we have the capability of doing. You can go back to main, Jason. There's a lot of stuff that we have the capability of doing with the system that people just aren't taking advantage of yet. There's a lot of sensors out there. All of the sensor telemetry data can be used in conjunction with other switches in logical setups and then applied to other functions in the transmitter. We have the ability to use the digital input through the Hall effect sensors to tell you when, say, an up and go power system is fully deployed or fully retracted. That would prevent you from powering up inside the fuselage. All of that can be done in the transmitter. All of that simply needs the right information when you start programming. Hopefully this has kind of given you an idea of what you want to do before you start trying to tackle the sequence. Getting the right information, knowing exactly when you want things to happen, and kind of giving yourself a roadmap. I am definitely not an artist, but hopefully that gave you an idea of what you want to do. You'll figure out the best way to do that for yourself. But it's always best when you're programming to start with a really good game plan and all of the information that you need and knowing exactly what you're trying to achieve. If there's anything in this video or anything that you saw that you have more questions on, things that maybe didn't get answered here, which ESC provides real-time telemetry? That would be the Mezen Pro Series ESC. None of the other ESCs provide real-time telemetry. If you're using those other ESCs, you can add the sensors like the Jeti MUI sensor for current, capacity, and voltage, MRPM, or the temperature sensor to give you the data that would come from that Mezen ESC. Very cool. Somebody else jumped on it, and everybody's really killing it on the comments today. We appreciate all of your questions. If there are things that you do want to see in the video, make sure you reach out. You just saw that the banner pop by a second ago. Make sure you like and subscribe. We are going to be covering some other topics here. We're going to go ahead and I believe next week we're going to be running with the sailplanes. So we're going to go into some of the different formats of sailplanes, some of the construction differences between them, and maybe help you decide what's best for you. And if you haven't flown a sailplane, maybe get you hooked, show you a few different things you hadn't seen. You know, it's not all sitting in a lawn chair looking up the sky flying an airplane. Some of it is extremely fun, extremely exciting, and will keep you really engaged. I hope you guys join us next week. We can't wait to see you back here.